Imagine trying to withdraw cash, only to find the ATM completely dead. At the airport, ticketing systems are locked up. Even emergency networks are struggling. The infection spread without a single user opening a phishing email, downloading a file, or clicking a link. This total infrastructure collapse happened in less than 10 minutes. Security teams realized that critical global networks could be dismantled instantly, even when every individual user followed perfect security protocol. This diagram compares the weapon responsible, a worm called SQL Slammer, to everyday data. At exactly 376 bytes, it occupies less space than a standard text message. Within that tiny data packet sat a specific set of instructions capable of overwhelming the global internet. Because the code was small enough to fit inside a single UDP packet, it traveled without the overhead required by larger files. This minimal footprint allowed it to fire across the network at the maximum possible speed. The clock started at 5:30 a.m. UTC on January 25, 2003. At the time, global businesses used Microsoft SQL Server as the foundational database for their customer and financial records. A vulnerability lived within the SQL Server resolution service. Although Microsoft had released a patch to fix this flaw 6 months earlier, thousands of organizations had not yet installed it. The disaster was the result of a widespread breakdown in basic corporate IT maintenance. Once Slammer identified a target, it bypassed the hard drive entirely. It lived only within a server's temporary memory, or RAM. Inside the memory, the worm executed a simple instruction: find vulnerable servers, shoot a copy of itself into them, and force those new victims to repeat the cycle. This network map illustrates the compounding math of the infection. Every infected server instantly creates more attackers, causing the number of victims to double every few seconds. Because every compromised machine is constantly shouting at random IP addresses to find new targets, the sheer volume of requests floods the physical cables connecting the servers. By multiplying at this rate, the worm weaponized the internet's own architecture against itself, creating a massive, self-inflicted, distributed denial of service attack. Pulling back to a global view, we can see the scale at the 10-minute mark. By 5:40 a.m., over 75,000 servers worldwide were infected. Digital congestion translated into physical failures. Bank of America ATMs went offline, and major airport ticketing systems crashed. In South Korea, the volume of automated scanning traffic was so heavy it bogged down the country's national connectivity, causing internet speeds to drop dramatically across major commercial districts. The worm's power came from its efficiency. It generated a relentless stream of junk data that physically clogged the pipes of the entire global internet. When the traffic subsided and systems were rebooted, investigators analyzed why the defenses failed so completely. The investigation found that organizations were routinely ignoring critical patches for months at a time, while simultaneously leaving sensitive database servers exposed to the public internet. Furthermore, security teams were caught without protocols for malware that could spread at an exponential rate, leaving them with no window to react. The event highlighted how a single unpatched vulnerability in a common software could bypass traditional defenses and disrupt international commerce in minutes. In the years following the attack, the industry shifted toward automated patch management and moved critical database services behind much stricter, more restrictive firewalls. Even with these changes, the asymmetry of the event remains a reminder of the internet's scale. A 376-byte script, a snippet of code shorter than a typical paragraph, brought global systems to a halt. Modern defenses are far more robust, yet the digital world remains highly interconnected. A single forgotten update on one critical server is all it takes to invite the next collapse.